Scientists debate aliens. Well, that's not exactly the title. The article can be found online. It's in Quantum magazine and under the subject of astrobiology. And the exact title is Scientists Debate Signitures of Alien Life. And it's subtitled, Searching for Signs of Life on Faraway Planets, Astrobiologists Must Decide Which Telltale Biosignature Gases to Target. That is, if you want to find out if life is there, what kind of an atmosphere do you expect? And it's by Natalie Watchover, and it's just this week. So, the article begins, huddled in a coffee shop one drizzly Seattle morning 6 years ago, the astrobiologist Sean Goldman stared blankly at his laptop screen, paralyzed. He'd been running a simulation of an evolving planet. That just means a planet that's changing over time. When suddenly oxygen started accumulating in the virtual planet's atmosphere. Up the concentration ticked from 0 to 5 to 10%. Is something wrong, his wife asked? Yeah. The rise of oxygen was bad news for the search of extraterrestrial life. Why? Because this virtual planet didn't have any extraterrestrial life, and yet it had oxygen. After millennia of wondering whether we're alone in the universe, one of mankind's profound and probably earliest questions beyond what are you going to have for dinner, as the NASA biologist Lynn Rothschild put it, the hunt for life on other planets is now ramping up in a serious way. Thousands of exoplanets, or planets orbiting stars other than the Sun, have been discovered in the last decade. Among them are potential super-Earths, sub-Neptunes, hot Jupiters, and worlds such as Kepler 452b, whose picture is behind the print on the screen. Well, whose artist's representation is behind. Let's be accurate here. A possibly rocky, watery Earth cousin located 1,400 light years from here. Starting in 2018 with the expected launch of NASA's James Webb Space Telescope, astronomers will be able to peer across the light years and scope out the atmospheres of the most promising exoplanets. They will look for the presence of biosigniture gases, vapors that could only be produced by alien life. They'll do this by observing the thin ring of starlight around an exoplanet while it is positioned in front of its parent star. Gases in the exoplanet's atmosphere will absorb certain frequencies of the starlight, leaving telltale dips in the spectrum. As Domagoj Goldman, then a researcher at the University of Washington's Virtual Planetary Laboratory, well knew, the gold standard in biosignature gases is oxygen. Not only is oxygen produced in abundance by Earth's flora, and thus possibly other planets, but 50 years of conventional wisdom held that it could not be produced at detectable levels by geology or photochemistry alone, making it a forgery-proof signature of life. Oxygen filled the sky on Domagoj Goldman's simulated world, however, not as a result of biological activity there, but because extreme solar radiation was stripping oxygen atoms off carbon dioxide molecules in the air faster than they could recombine. This biosignature could be forged after all. The search for biosignature gases around faraway exoplanets is an inherently messy problem, said Victoria Meadows, an Australian powerhouse who heads VPL. In the years since Domagoj Goldman's discovery, Meadows has charged her team of 75 with identifying the major oxygen false positives that can arise on exoplanets, as well as ways to distinguish these false alarms from true oxygenic signals of biological activity. Meadows still thinks oxygen is the best biosignature gas, but, she said, if I'm going to look for this, I want to be sure that when I see it, I know what I'm seeing. Meanwhile, Sarah Seeger, a dogged hunter of twin Earths at the Massachusetts Institute of Technology, who is widely credited with inventing the spectral technique for analyzing exoplanet atmospheres, is pushing research on biosignature gases in a different direction. Seeger acknowledges that oxygen is promising, but she urges the astrobiology community to be less terracentric in its view of how alien life might operate, to think beyond the Earth's geochemistry and the particular air we breathe. My view is that we do not want to leave a single stone unturned. We need to consider everything, she said. As future telescopes widen the survey of Earth-like worlds, it's only a matter of time before a potential biosignature gas is detected in a faraway sky. It will look like the discovery of all time, evidence that we are not alone. But how will we know for sure? Scientists must quickly hone their models and address the caveats if they are to select the best exoplanets to target with the James Webb Telescope. Because of the hundreds of hours it will take to examine the spectrum for each planetary atmosphere, and the many competing demands on its time, the telescope will likely only observe between 1 and 3 Earth-like worlds in the habitable Goldilocks zones of nearby stars. In choosing from a growing list of known exoplanets, the scientists want to avoid planetary circumstances in which oxygen false positives arise. We're looking at maybe putting our eggs, if not all in one basket, at least in only a couple of baskets, Meadows said. So it's important to try and figure out what we should be looking for there, and in particular, how we might get fooled. Breath of life. Oxygen has been regarded as the gold standard since the chemist James Lovelock first contemplated biosignature gases in 1965 while working for NASA on methods of directing life on Mars. I'm not reading the whole thing. It takes too long. Lovelock reasoned that the presence of life on other planets could be deduced by looking for incompatible gases in their atmospheres. If two gases that react with each other can both be detected, then some lively biochemistry must be continually replenishing the planet's atmospheric supplies. In Earth's case, though it readily reacts with hydrocarbons and minerals in the air and ground to produce water and carbon dioxide, diatomic oxygen, O2, comprises a steady 21% of the atmosphere. Oxygen persists because it is poured into the sky by plants, algae, and cyanobacteria. If photosynthesis ceased, the existing oxygen in the sky would react with elements in the crust and drop to trace levels in 10 million years. Eventually, Earth would resemble Mars, with its carbon dioxide-filled air and rusty oxidized surface. Evidence, Lovelock argued, that the red planet does not currently harbor life. But while oxygen is a trademark of life on Earth, why should that be true elsewhere? Meadows argues that photosynthesis offers such a clear evolutionary advantage that it is likely to become widespread in any biosphere. Photosynthesis puts the biggest source of energy on any planet, its sun, to work on the most commonplace of planetary raw materials, water and carbon dioxide. If you want to have the uber metabolism, you will try and evolve something that will allow you to use sunlight, because that's where it's at, Meadows said. Fascinating line of argument. No question of whether you could get photosynthesis or not. Obviously you can, because we have it on Earth. And because everybody knows God wasn't involved, that means that you can do it without having to have intelligent design. So therefore, if it can happen here, it should happen anywhere, and it should give you such an advantage that it should take over. Yes, Ariel.
Well, in order to start life, you must not have oxygen. You can destroy all those molecules. Are they taking into account the complex picture you have to have there to get this thing to work?
Well, see, in that case, there must not have been oxygen at the beginning. Otherwise, life wouldn't be here.
Yeah, well, you got to have a mechanism to have no oxygen, then you got to have oxygen. Things much more complex.
Yes, they do. But you notice, I mean, what's happening here is the argument, but it happened, is being subliminally used. Since it happened, therefore it must be easy to happen. And it must be easy to happen without any divine intervention or even any alien intervention.
Are you going to have photosynthesis without life to start out and produce your oxygen?
Well, no. See, you see, life must be easy, and as you'll find out, and photosynthesis must be easy because it happened.
Okay, I got the message.
You think about it, and you think about the complexity of photosynthesis and the unlikelihood of it happening without somebody designing it. And you can see how the worldview just kind of elides over all of those difficulties. Diatomic oxygen also boasts strong absorption bands in the visible and inner infrared. The exact sensitivity range of both the $8 billion James Webb Telescope, that's right, you and my tax dollars are paying for this, and the Wide Field Infrared Survey Telescope, or WFIRST, a mission planned for the 2020s. With so many imminent hopes riding on oxygen, excuse me, Meadows is determined to know where the gotchas are likely to be. So far, her team has identified 3 major non-biological mechanisms that can flood an atmosphere with oxygen, producing false positives for life. On planets that formed around small, young M-dwarf stars, for instance, and this is one of the 3, I guess, intense ultraviolet sunlight can in certain cases boil down the planet's oceans, creating an atmosphere thick with water vapor. Probably ours too, but we'll leave that aside. At high altitudes, as VPL scientists reported in the journal Astrobiology last year, intense UV radiation splinters off the lightweight hydrogen atoms. These atoms then escape to space, the hydrogen, leaving behind a veil of oxygen thousands of times denser than Earth's atmosphere. Because the smallness of M-dwarf stars makes it easier to detect much smaller rocky planets passing in front of them, they are the intended targets for NASA's Transiting Exoplanet Study Survey satellite, TESS, a planet-finding mission scheduled to launch next year. The Earth-like planets that will be studied by James Webb Telescope will be selected from among TESS's finds. With these candidates on the way, astrobiologists must learn how to distinguish between alien photosynthesizers and runaway ocean boiling, which I think would have happened on the early Earth, if you think about it, which means we should have had oxygen, which means life shouldn't have started, but then life is here, so obviously it can't happen. In work that is now being prepared for publication, Meadows and her team show that a spectral absorption band from tetraoxygen loosely forms when oxygen O2 molecules collide. The denser the O2 in an atmosphere, the more molecular collisions occur and the stronger the tetraoxygen signal becomes. We can look for the O4 to give us a telltale sign that we're not just looking at a 1-bar atmosphere with 20% oxygen, like our own. Meadows explained, we're looking at something that just has massive amounts of oxygen on it. So they're looking for planets that are, in some cases, larger than Earth, like the one in the artist picture here. A strong carbon monoxide signal will identify the false positive that Donegal Goldman first encountered that drizzly morning in 2010. That is, carbon dioxide being dissociated into carbon monoxide and oxygen. Now, a research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, he says he isn't worried about oxygen's long-term prospects as a reliable biosignature gas. Oxygen false positives only happen in rare cases, he said, and the planet that has those certain cases is also going to have observational properties that we should be able to detect, as long as we think about it in advance, which is what we're doing right now. He and other astrobiologists are also mindful, though, of oxygen false negatives, planets that harbor life but have no detectable oxygen in their atmospheres. Both the false positives and false negatives have helped convince Sarah Seeger of the need to think beyond oxygen and explore quirkier biosignatures. Encyclopedia of Gases. If the diverse exoplanet discoveries of the past decade have taught us anything, it's that planetary sizes, compositions, and chemistries vary dramatically. By treating oxygen as the be-all, end-all biosignature gas, Seeger argues, we might miss something. And with the personal dream of discovering signs of alien life, the 44-year-old can't abide by that. I think proper English would be abide that. Even on Earth, Seeger points out, photosynthesizers were pumping out oxygen for hundreds of millions of years before the process overwhelmed Earth oxygen sinks, and oxygen started accumulating in the sky 2.4 billion years ago. Until about 600 million years ago, judged from a distance by its oxygen levels alone, Earth might have appeared lifeless. And of course, we don't want that to happen. If we're looking at a planet, it has life, and if you just wait another 600 million years, it'll have oxygen. That's not what we're really interested in. Meadows and her collaborators have studied some alternatives to oxygenic photosynthesis. But Seeger, along with William Baines and James Petkowski, are championing what they call the all-molecule approach. They're compiling an exhaustive database of molecules, 14,000 so far, that could possibly exist in gas form. On Earth, many of these molecules are emitted in trace amounts by exotic creatures huddled in ocean vents and other extreme milieus. They don't accumulate in the atmosphere. In other words, you couldn't see them as a planet passed in front of its sun. The gases might accrue in other planetary contexts, however. On methane-rich planets, as the researchers argued in 2014, photosynthesizers might harvest carbon from methane, CH4, rather than carbon dioxide, and spew hydrogen rather than oxygen, leading to an abundance of ammonia. The ultimate long-term goal is to look at another world and make some informed guesses as to what life might produce on that world, said Baines. Donegal Goldman agrees that thinking both deeply about oxygen and broadly about all the other biochemical possibilities is important. Meadows, however, questions the practicality of the all-molecules approach. In a 3,000-word email critiquing Seeger's ideas, she wrote, "After you build this exhaustive database, how do you identify those molecules that are most likely to be produced by life? And how do you identify their false positives?" She concluded, "You will still have to be guided by life on Earth and our understanding of planetary environments and how life interacts with those environments. In contemplating what life might be like, it's exasperatingly difficult to escape the only data point we have, at least for now." Uncertain odds, and this is where it gets really interesting to me. At a 2013 symposium, Seeger presented a revised version of the Drake equation, which we'll come back to. Frank Drake's famous 1961 formula for gauging the odds that SETI would succeed. Whereas the Drake equation multiplied a string of mostly unknown factors to estimate the number of radio broadcasting civilizations in the galaxy, Seeger's equation estimates the number of planets with detectable biosignature gases. With a modern capability or a modern capacity to look for any life, regardless of whether it's intellectually capable of beaming messages into space, the calculations of our chances of success no longer depends on uncertainties like the rareness of intelligence as an evolutionary outcome or the galactic popularity of radio technology. However, one of the biggest unknowns remains: the probability that life will arise in the first place on a rocky, watery, atmospheric planet like ours. Abiogenesis, as the mystery event is called, seems to have occurred not long after Earth accumulated liquid water, leading some to speculate that life might start up readily, even inevitably under favorable conditions. It happened, therefore it must be able to happen, and it happened rapidly, therefore it must be not too improbable. But if so, then shouldn't abiogenesis have happened multiple times in Earth's 4.5 billion year history, spawning several biochemically distinct lineages rather than a monoculture of DNA-based life? Well, yeah. John Burroughs, a microbiologist at the University of Washington who studies the origins of life, explained that abiogenesis might well have happened repeatedly, creating a menagerie of genetic codes, structures, and metabolism on early Earth. But gene swapping and Darwinian selection would have merged these different upstarts into a single lineage, which has since colonized virtually every environment on Earth, preventing new upstarts from gaining ground. What? In short, it's virtually impossible to tell whether abiogenesis was a fluke event or a common occurrence here or elsewhere in the universe. Think about that. We'll come back to it. Scheduled to speak last at the symposium, Seeger set a light-hearted tone for the after-party. I put it all in our favor, she said, positing that life has a 100% chance of arising on Earth-like planets, and that half these biospheres would produce detectable biosignature gases. Another uncertainty in her equation. Crunching these wildly optimistic numbers yielded the prediction that 2 signs of alien life would be found in the next decade. You're supposed to laugh, Seeger said. Meadows, Seeger and their colleagues agreed that the odds of such a detection this decade are slim. Though the prospects will improve with future missions, the James Webb Telescope will have to get extremely lucky to pick a winner in its early attempts. And even if one of its targeted planets does harbor life, spectral measurements are easily foiled. In 2013, the Hubble Space Telescope monitored the starlight passing through the atmosphere of a mid-sized planet called GJ1214b. But the spectrum was flat with no chemical fingerprints at all. Seeger and her collaborators reported in Nature that a high-altitude layer of clouds appeared to have obscured the planet's sky from view. In other words, from the perspective of our ability to see, it had no atmosphere. And that's the end of the article. And when I read it, I was reminded of an article that was written by Michael Crichton, the person who wrote the novel Jurassic Park. He has some very interesting ideas on terms of science. And he wrote an article called Aliens Cause Global Warming in 2003. We're going to look at only a bit of it. It's all over the internet on Michael Crichton's original website. As far as I can tell, the link is broken. But this is probably the most official place to find it, although there are a number of other places as well. You can Google it and find it all over. He starts out by saying, "My topic today sounds humorous. Aliens cause global warming. But unfortunately, I am serious. I'm going to argue that extraterrestrials lie behind global warming. Or to speak more precisely, I will argue that a belief in extraterrestrials has paved the way in a progression of steps to a belief in global warming. Charting this progression of belief will be my task today." And I'm going to not read the whole thing, obviously, not even major parts of it. But there are some pieces in it that I find fascinating. "Even as a child, I believed that science represented the best and greatest hope for mankind. Even to a child, the contrast was clear between the world of politics, the world of hate and danger, of irrational beliefs and fears, of mass manipulation and disgraceful blots on human history. In contrast, science held different values, international in scope, forging friendships, and working relationships across national boundaries and political systems, encouraging a dispassionate habit of thought and ultimately leading to fresh knowledge and technology that would benefit all mankind. The world might not be a very good place, but science would make it better. But I did not expect science merely to extend lifespan, feed the hungry, cure disease, and shrink the world with jets and cell phones. I also expected science to banish the evils of human thought, prejudice and superstition, irrational beliefs and false fears. I expected science to be, in Carl Sagan's memorable phrase, a candle in a demon-haunted world. Those of you who may remember, Carl Sagan wrote, I think, a book, A Candle in the Dark, and that book was reviewed by Richard Lewontin in a very famous essay where his kind of central theme of the central paragraph of the entire review was, "We cannot allow a divine foot in the door," which is interesting. And here, I am not so pleased with the impact of science, getting back to Crichton. Rather than serving as a cleansing force, which is the way Carl Sagan viewed it, science has in some instances been seduced by the more ancient lures of politics and publicity. And if you keep going in the article, you'll find out that Carl Sagan was guilty of some of this himself. Cast your minds back to 1960. In Green Bank, West Virginia, at the new National Radio Astronomy Observatory, a young astrophysicist named Frank Drake runs a 2-week project called OSMA to search for extraterrestrial signals. A signal is received, to great excitement. It turns out to be false, but the excitement remains. In 1960, Drake organizes the first SETI conference and came up with the now famous Drake equation, N equals N star, FP, NE, FL, FI, FC, FL. Now, those, I think, are always supposed to be subscripts, although everywhere I've looked, they've always been printed straight across. In Michael Crichton's work, I suspect that that's a function of the fact that he didn't have subscripts at his command. Where N, and I think that should read N star, is the number of stars in the galaxy, in the Milky Way galaxy. FP is the fraction with planets. NE is the number of planets per star capable of supporting life. FL is the fraction of planets where life evolves. FI is the fraction where intelligent life evolves. And FC, actually the fraction of planets with life where intelligent life evolves. And FC is the fraction that communicates, the fraction of intelligences that can communicate. And FL, capital L, is the fraction of the planet's life during which the communicating civilizations live. Excuse me. So I want to point out something that Crichton doesn't precisely point out, but the fact of the matter is that that is a perfectly valid equation. That if you had numbers to apply to it, it would be exactly right all the time. However, Crichton does point out the problem with that equation. This serious-looking equation gave SETI a serious footing as a legitimate intellectual inquiry. The problem, of course, is that none of the terms can be known, and most cannot even be estimated. The only way to work the equation is to fill in with guesses. And guesses, just so we're clear, are merely expressions of prejudice. Nor can there be informed guesses. If you need to state how many planets with life choose to communicate, there is simply no way to make an informed guess. It's simply prejudice. As a result, the Drake equation can have any value from billions and billions to zero. An expression that can mean anything means nothing. Speaking precisely, the Drake equation is literally meaningless and has nothing to do with science. I take the hard view that science involves the creation of testable hypotheses. By the way, I also take the hard view. The Drake equation cannot be tested, and therefore SETI is not science. SETI is unquestionably a religion. Faith is defined as a firm belief in something for which there is no proof. I would prefer to say that that's a false faith, but the belief that the Quran is the Word of God is a matter of faith. The belief that God created the universe in 7 days is a matter of faith. The belief that there are other life forms in the universe is a matter of faith. There's not a single shred of evidence for any other life forms, and in 40 years of searching, none has been discovered. There's absolutely no evidentiary reason to maintain this belief. SETI is a religion. Interesting. That's hard on him. And of course, it is true that untestable theories may have heuristic value. Of course, extraterrestrials are a good way to teach science to kids, but that does not relieve us of the obligation to see the Drake equation clearly for what it is: pure speculation in quasi-scientific trappings. The fact that the Drake equation was not greeted with screams of outrage, similar to the screams of outrage that greet each creationist new claim, for example, meant that now there was a crack in the door, a loosening of the definition of what constituted legitimate scientific procedure. And soon enough, pernicious garbage began to squeeze through the cracks. I'm going to come back to that quote, too. And then he talks about nuclear winter. And in the middle of talking about nuclear winter, he gives a comment that I think deserves special emphasis, so I'm going to do that. I want to pause here and talk about this notion of consensus. Somebody's been defending nuclear winter on the basis of scientific consensus. I regard consensus science as an extremely pernicious development that ought to be stopped cold in its tracks. Historically, the claim of consensus has been the first refuge of scoundrels. It is a way to avoid debate by claiming that the matter is already settled. Whenever you hear the consensus of scientists agrees on something or other, reach for your wallet, because you're being had. Let's be clear. The work of science has nothing to do, whatever, to do with consensus. Consensus is the business of politics. Science, on the contrary, requires only one investigator who happens to be right, which means that he or she has results that are verifiable by reference to the real world. In science, consensus is irrelevant. What is relevant is reproducible results. The greatest scientists in history are great precisely because they broke with the consensus. There is no such thing as consensus science. If it's consensus, it isn't science. If it's science, it isn't consensus. Period. In addition, let me remind you that the track record of the consensus is nothing to be proud of. Let's review a few cases. In past centuries, the greatest killer of women was fever following childbirth. 1 woman in 6 died of this fever. In 1795, Alexander Gordon of Aberdeen suggested that the fevers were infectious processes, and he was able to cure them. The consensus said no. In 1843, Oliver Wendell Holmes claimed puerperal fever was contagious and presented compelling evidence. The consensus said no. In 1849, Semmelweis demonstrated that sanitary conditions virtually eliminated puerperal fever in hospitals under his management. The consensus said he was a Jew, ignored him, and dismissed him from his post. And he died insane, and so therefore he must be wrong. There was, in fact, no agreement on puerperal fever until the start of the 20th century. Thus, the consensus took 125 years to arrive at the right conclusion, despite the efforts of the prominent skeptics around the world. Skeptics who were demeaned and ignored, and despite the constant ongoing deaths of women. There's no shortage of other examples. In the 1920s in America, tens of thousands of people, mostly poor, were dying of a disease called pellagra. The consensus of scientists said it was infectious, and what was necessary was to find the pellagra germ. The U.S. government asked a brilliant young investigator, Dr. Joseph Goldberger, to find the cause. Goldberger concluded that diet was the crucial factor. The consensus remained wedded to the germ theory. Goldberg demonstrated that he could induce the disease through diet. He demonstrated that the disease was not infectious by injecting the blood of a pellagra patient into himself and his assistant. They and other volunteers swabbed their noses with swabs from pellagra patients, swallowed capsules containing scabs from the pellagra rashes in what were called Goldberger's filth parties. Nobody contracted pellagra. Interesting research methods. The consensus continued to disagree with him. There was, in addition, a social factor. Southern states disliked the idea of poor diet as the cause because it meant that social reform was required. They continued to deny it until the 1920s. Result, despite a 20th century epidemic, the consensus took years to see the light. Probably every school child notices that South America and Africa seem to fit together rather snugly. And Alfred Wegener proposed in 1912, and other people before him, by the way, that the continents had in fact drifted apart. The consensus sneered at continental drift for 50 years. The theory was most vigorously denied by the great names of geology until 1961, when it began to seem as if the seafloors were spreading. The result? It took the consensus 50 years to acknowledge what any school child sees. Shall we go on? The examples can be multiplied endlessly. Jenner and smallpox, Pasteur and germ theory, saccharin, margarine, repressed memory, fiber and colon cancer, hormone replacement therapy. The list of consensus errors goes on and on. Finally, I would remind you to notice that where the claim of consensus is invoked. Consensus is invoked only in situations where the science is not solid enough. Nobody says the consensus of scientists agree that E equals mc squared. And by the way, that's, again, it's originally right there. I assume that got lowered sometime when it was transcribed to something that didn't have superscript. Nobody says that the consensus is that the sun is 93 million miles away. It would never occur to anyone to speak that way. Now, my take on all this, looking for planets many light years away from Earth is difficult enough. We saw that looking at some of the data that was there. Trying to determine the composition of their atmospheres is even more difficult. And the latest try, which I think is the first published try, Couldn't find an atmosphere, as you may remember. Clouds can get in the way. The signal is very faint. Just tough. Right now, we have no data to indicate the presence of life on other planets. But, that's interesting enough, but I'm more interested in the assumptions about the origin of life. If life originated soon after it was possible for life to exist on this planet, which is currently what is being claimed, then life must be probable. Codes can just merge. Remember the quote. We'll pull it up again. Abiogenesis might well have happened repeatedly, creating a menagerie of genetic code structures and metabolism on early Earth. But gene swapping and Darwinian selection would have merged these different upstarts into a single lineage, which has since colonized virtually every environment on Earth, preventing new upstarts from gaining ground. In short, life is virtually impossible to tell whether abiogenesis was a fluke event or a common occurrence, here or elsewhere in the universe. Doesn't that strike you as odd? Think about it a little bit. The reason there isn't an equivalent of a Mac and a Windows on Earth is because programs got transferred back and forth. And pretty soon you had a Mac Windows composite. Codes just move across from one coding setup to another. Does that make sense? This is somebody, I think, who's trying desperately to convince himself that there can't be any evidence for life because it's all too mixed up. Not realizing what it would take to mix things up. Higher experimental improbabilities and high theoretical improbabilities just don't matter. Remember the article by Kunin who said, taking wildly optimistic estimates, that the probability of getting life on Earth one time was 10 to the 1,018 or so. And those are wildly optimistic assumptions. That equation alone, that point alone in the Drake equation should be so close to zero as to completely wipe out. The fact of the matter is it's surprising we're here if you assume no intelligent input. And therefore, the expectation of finding anything else anywhere else is so far towards zero as to not be worth considering. What it means is, if there is intelligent life out there, it must be intelligently designed. That's what it means. But the answer to all that is, but it happened. And of course, we know it didn't happen with intelligent design. So therefore, it must not be that hard to do. Talk about non sequiturs. I am sorry, this is religion, not science. Come back to that quote. The fact that the Drake equation was not greeted with screams of outrage, similar to the screams of outrage that greet each new creationist claim, for example, meant that now there was a crack in the door loosening of the definition of what constituted a legitimate scientific procedure. I would like to suggest to Crichton, although I can't do that anymore since he's dead, but I would like to suggest to those who are reading it that maybe there was a problem at the beginning. That maybe geology was set up with the idea of freeing it from Moses. And that what actually happened was that the creationist new claims are greeted with outrage for the precise same reason that all of these other scams are going on. That was a scam to begin with. In fact, nobody believes Lyell anymore in his major claims. Look at what happened to the idea that things that don't happen today didn't happen back then. That's been thoroughly disproved by Brett's flood. And it happened apparently multiple times in the past. Maybe the exclusion of creationism was the first in a long line of changing the definition of what constituted legitimate scientific procedure. And we have sown the wind and we're reaping the whirlwind. I agree with Crichton that science is tied to experiment. That makes carbon-14 in fossil carbon science. It also makes biogenesis currently not science, because it's not tied to experiment. The concept of science needs to be rethought. Science is not, or at least should not be, applied materialistic philosophy. But that's my opinion. Now it's your turn. Comments, and we'll send the mic to you.
First.
Yes.
How do they pretend to measure oxygen in a planet that's millions of miles away?
Oh, well, the principle is simple. The technology is very difficult. The principle is that if you put a gas in front of a continuous spectrum emitter, that is to say, something that puts out light of all different varieties, so that you get, red light, green light, and blue-green, and blue-green, and all that stuff, and all in a continuous spectrum. That if you put certain things in front of it, they will absorb light in specific bands. And oxygen has its own little specific bands that it will absorb light in. So that if you were to look at it, we can do this on Earth. In fact, that was one of the ways we used to measure potassium, is by heating stuff up, causing potassium vapor to be in a flame, and then measuring how much of a particular wavelength got absorbed by the potassium. And it's in the very high blue. When potassium is heated, it gives you a purple flame.
So you look at this with the telescope.
You look at it with a telescope that's hooked up to a spectroscope, so that you can tell which, and it spreads it out, and you got these bands of absorption coming through. But as you can imagine, if you're looking at a star that's a long ways away, and you're expecting a 0.1% drop in the particular band, or perhaps less, the measurement becomes, shall we say, difficult.
Thank you.
Yes.
Your conclusion is, I think, the important issue here. It's much broader than the topic, although the topic is highly illustrative of communal thinking in science. Whatever happens to be vogue at a certain time, this is a fashion. You kind of follow these fashions around in science. Right now, this happens to be a fashion in this particular area. But I think deeper than that, I would raise the question of rationally, why do you arbitrarily exclude God from the equation? In other words, you can speculate all kinds of things, and he gave a whole bunch of examples there. You can speculate all kinds of things. DNA codes arising, those things can't work until the whole code is set up. I mean, this is, and so on. But
And to fuse two codes is just nuts.
yeah, but try and mention God as a possibility? No way. Not allowed in the scientific literature. What does matter with our reasoning, the reasoning of our scientists, that they'll speculate about all these wild ideas, but they won't allow God mentioned as a possible cause in the scientific literature. There's something radically or rationally wrong here that we need to emphasize in this picture. Why are we so bent? By we, I'm saying the scientific community. Why are we so bent on not allowing the possibility of a God in this picture? While we sit there and present all kinds of wild ideas, and publish them in the literature and so on and so on. Okay, you can speculate about certain things, but you can't speculate about God.
Yeah, yeah.
It seems interesting to me that you can say life is here, therefore it must have happened easily. And when you look at the probabilities of life occurring, they get to be astronomical, which should mean the probabilities of something influencing life be here or 1 over that number, or the reverse of that, which would imply that the data screams that there must be a God. And if you can say life exists, therefore it must happen easily, you certainly could say, but 1 or 10 to the 1,000 whatever odds are that it was done, that there is something that caused the life.
Then the odds of it
because
being
life
done
exists, therefore it must be.
Yeah, but the odds of it being done by design must be 1 minus 10 to the minus 1018, and that's a minimum estimate.
Correct. And it's the same rational thought that life is here, therefore it must have happened by evolution. It's just that the differences between the two are 10 to the 1,000 whatever, one direction or the other, at a minimum.
Yeah. No, I agree. Comments? Oh, we have one way in the back. Go ahead and pass it on.
But there's tricky tricks that make the improbable supposedly probable. Like having an infinite number of universes.
Right. Right.
I mean, it puts in the realm you can't prove it. And yet that's their way out. There's also the anthropic principle. I think that even if it's terribly improbable here, well, if intelligence, even if it's rare, if it exists just once, then those people will be pondering these questions. So that explains the situation. Yeah. I'm sure that there's other such little tricks.
Well, the thing to keep in mind is that, but it happened is very dangerous for science, for at least atheistic science. Because you can use the same rationality to say, well, what's the probability of being able to walk on water? And your response to, well, it's 10 to the minus whatever, and you say, but it happened. They got no argument. Well, it couldn't have. How do you know it couldn't have happened? There's a finite possibility, right? See, and this is the danger of going to multiple universes, is because you have no criterion to say that something didn't happen because things like that don't happen in our universe. Well, maybe 99.999 some, 1,000 nines % of the time it doesn't. But there's always that one time. And we saw it. And so you're stuck. And these people are playing with fire and they don't know it.
I think reverse causality might be another one of these things where no matter how unlikely it was that life could get started, that because we existed in the future, from back then it caused this highly improbable thing to happen, if I understand reverse causality.
Yeah.
I'm interested in the implications of this presentation with reference to science being religion and our interpretation of religion. I happen to think that religion is a very good thing myself. I happen to also realize that there is no sharp line between data and interpretation, and that we all indulge in interpretations of all kinds of things, and somewhere here you want to establish certain degrees of interpretation are too wild to be acceptable, and others not. And statistics is a good useful tool here in this question. But I don't think we can use the absolute that religion is bad, and that. But it's useful because scientists, they abhor the word. It's useful in the conversation here. But to me, a certain degree of interpretation is necessary. And but when it gets too wild, I think we need some new terms here to call it science is wrong, probably, although it's, as long as it excludes God, it's science.
See, I agree with you in an important sense. I think there are two different concepts that are being blurred and merged together in modern parlance. One of them is what Crichton and I see as the hard science, the study of the reproducible. If it's not reproducible, you can't study it that way. Now, maybe you can study it as history, maybe you can study it in different other ways, but if you can't reproduce it, it's not science, period. And the other one is another definition that has been actually proposed by philosophers of science, and that is science is what scientists do. And that is almost by definition consensus. And those are two very distinct ways of looking at science. And Crichton is finding himself reacting vigorously against number two because it can't be squared with number one. And I agree wholeheartedly. A comment there and then down here, I guess.
Yeah, then I'll get it to him. Is there a value to some level of consensus? If you're, for example, a teacher and you're needed to teach science, how do you know, and if there's disagreement on some particular topic, how do you know what to teach on that topic?
Well, there are some people who would argue that you should teach the controversy. And maybe that's a good thing. Some people will say, yeah, that's the way you should do it. And I would argue that any time you silence somebody's view without actually showing how it contradicts known facts, you're actually not doing science. You're doing Scientology or whatever you want to call it.
I was reminded of science this week. I had an unfortunate event. While driving through a parking lot, somebody hit the side of my vehicle. And, of course, it was all my fault. until the police arrived and looked at the tracks and the way my vehicle had gotten pushed. And he said, this was in Nairobi, Kenya. And he says, do you want me to write you up, or are you going to settle with him? And at that point, the owner of the vehicle said, do you have a shop you like? I said, yes, I do. He says, let's go there and I'll settle with them and you'll be good. So the vehicle is now fixed and we're all good. But the science was very clear in that one instance. There are other cases that I was also reminded of this week, given some of the media stuff. Nicole Brown Simpson. We know she died. There's no question she was killed. Who did it? There's all kinds of evidence and all kinds of interpretations of the same data. And there are a number of biases when you talk to people into their interpretation of the data as to what happened, who did it. And if you look at the biases, what you really see underlying those biases in the interpretation of the data is there's a worldview that says, if I interpret it your way, my worldview is going to collapse. Therefore, I can't interpret it your way. And I think this is what's happening to many of these people. You know, the reproducible science, Adventists and atheists have no problem with. You know, the atomic bomb, we all know how it works. There's no great mystery there.
And we know that it works.
And we know that it works, and rockets are predictable, and there's a whole lot of science that we can all agree on. There's, you know, when you have a crime scene, there's an awful lot of things, when you didn't see it happen, there may or may not be reproducibility of it. And Earth is, in some senses, like a crime scene. It happened. There's no question there is life. I think we can all agree to that. There is life. We're all part of that.
Once upon a time, there was not life. So it started somehow.
It started somehow. The question is how. And unfortunately, we can't go back in history and do it again. There's no way to go back to a planet with no life.
And even if we did, we wouldn't be absolutely assured that this is the way it happened in ours.
But the point is, to go to a planet, the moment we go to another planet, we're introducing life into it. The moment we're injecting things into it, and so all of a sudden, you're caught in a situation where you cannot reproduce the past, and therefore your worldview has to help you interpret that data.
Yeah, and the worldview can push people into interpreting data in ways that, in other contexts, they never would.
Yeah, the prior comment made my question a little bit more understandable. I was going to ask, in view that forensic science is a respectable science, what are the limits? Where is it that forensic science could go off? In other words, when you have a scientific consensus for something, sometimes it's pretty reasonable, and sometimes there's reason to be a fair deal of skepticism. What would be the way to distinguish between what's real or what's reasonable and what's not?
Okay, we have a comment way in the back that probably reverts to that. Go ahead and come and get the mic if you can, because we want that. We want it on. We want it recorded.
Perhaps an answer to this question could be if the stakes are high, then the suspicion for bias should be high. That if it's a crime scene and it's not OJ, it's just somebody, then perhaps the stakes are lower. Whereas if it's really high, then perhaps people will felt compelled to start fudging things or misinterpreting or biasing, basically.
Yeah, no, that's right. And when science impacts in those areas, one can expect for people to try desperately to bend the effects of the science. Challenge everything possible, because the conclusion is not one they want to reach. And I guess one of the things you could do is step back a little bit and see who is bending the science hardest and who is relatively taking it straightforwardly. And that might give one at least a clue as to who's actually following science and who's not. I'm using science in the sense of good science, in the sense of stuff that we know to be reproducible.
Might there be a place for a group of scientists who are specifically they're trying to look at all the data and not make an absolute determination, like for sure it happened this way, for sure that, but saying, looking at all of the information, it seems as though it's about here in terms of, drawing a line, but the line might be 75% this way.
Maybe we should revisit that Crichton article, because I think it is absolutely fascinating.
It's amazing.
Anyway, come on back. We'll have some more fun next week. And well, we may go further into that Crichton article so that you can see his and I think it has direct relevance to how we view creationism, because I think that some of the same principles are involved. Anyway.